Hello, I'm Jim Brown and I'm the founder of H2O Analytics Corporation. We're based in Austin, Texas, and we're dedicated to helping utilities make better use of the data that resides in their computing systems. Our software product is a cloud-based system that pulls together data from a variety of in-house utility systems as well as data from numerous public and commercial external data providers. The system applies analytic processes to that data to help you spot trends, identify anomalies, and visualize large volumes of data quickly and easily. The system's tailored to the specific needs of utilities and has pre-built interfaces into all of the systems and data sources that I'll be discussing here. And it's cloud-based. So this makes for very simple and quick implementations and allows you to start deriving value from the software very quickly. In addition to the analytic data processing, the software has a very robust customer notification capability that allows you to communicate with your customers via phone, email, text messaging, the web, and social media. The system works by interfacing with all of your existing in-house software products, including your billing system, your GIS, your customer metering, whether that's manual read meters, drive-by AMR technology, a fixed-base network, AMI system, or a hybrid solution. We also tie into your SCADA to gather operational data and your work order or service order system. The data from these systems is combined with several external data sources, including county appraisal databases, federal census data, and weather data. Data from these sources flow into the system and are continually processed by our analytic engine, which prepares graphical management dashboards for you and your customers to easily visualize information. Additionally, the system detects what we call business events, such as potential water leaks, and automatically notifies relevant parties, including your staff and the affected customers, via phone, email, and text messaging. This ability to enhance your communications with your customers is a key feature of H2O Analytics, and it really differentiates us from many of the other analytic offerings in the market. So many times when you're evaluating utility data with an analytics engine, it's going to detect events that require action. And in order to spur that action, you need to communicate. For example, it may be, hey, go fix this leak. Or it might be, your water usage has exceeded your normal usage ranges. Or here are some ideas on how you can conserve water. Or even, if you don't pay your bill, we're going to cut you off next Tuesday, etc. So analytics alone will only get you part of the way there. And in fact, an analytics engine alone is just going to create a big stack of events that need action or follow-up without giving you an efficient way to drive that action. Conversely, a customer notification system without an analytics capability isn't going to get you the full efficiency gain that's possible. For example, a lot of systems these days, with conservation being front in mind in so many parts of the country, are starting to drive notifications to customers whose usage exceeds some threshold. But most systems really just drive that off of some fixed percentage, system-wide percentage. So for example, if the customer's usage this month exceeds 150% of what their average usage is, or what their usage this month last year was, then we're going to drive a notification. And the problem with this rudimentary approach is you're going to get a ton of false positives. I mean, in a 10,000 user system, you may get thousands of false positives off of that. And the reason is a customer whose usage is consistently, say, 4,000 gallons a month and suddenly spikes to 6,000. Well, that looks like a lot from just a pure percentage point of view, but 2,000 gallon gain or even 6,000 gallons usage is probably not really anything that is certainly indicative of a problem. And you're gonna generate more phone calls asking what's going on, then you're going to drive benefit by automatically notifying customers of something like that. So what a more robust analytic algorithm will do is take into account a number of signals, including system-wide averages, seasonality, um, seasonality across a spectrum of customers, say residential or commercial or industrial, and what an individual account's moving averages are, for example, what an individual account did this month, last year, and over time, over history. So all of these signals can be fed into a more robust model that's going to filter out all those false positives and really let the systems just zero in on the ones that are truly anomalies. So by bringing these two capabilities together, we enabled you to achieve a high level of really advanced, very proactive customer communication with almost zero additional effort on the part of utility staff. Bulk notifications, when you need to contact your entire customer base, such as for a boil notice, can be achieved through literally just a few clicks of your mouse and can be blasted out to thousands of customers in just minutes. And the key thing is without tying up any of your phone lines. Monthly and hourly usage data can be pushed to your customers via email or pulled by them through our interactive widgets embedded in your existing website or via a smartphone app. Customer communications can also be focused geographically by selecting customers on a Google map. And this is really useful for service outage notifications, and we kind of think of it as the 21st century version of the good old door hanger, but much faster and easier to distribute, especially in the dead summer heat or in the freezing cold winter temperatures. Many notifications are driven automatically by the analytics engine, including continuous flow and high usage alerts. And these are detected through continuous evaluation of your meter data. And by interacting with the billing system, we can drive past due and cutoff warning notifications. And some of our customers have modified their tariff so that these phone or email notifications are the official notice of past due. And so imagine eliminating a few thousand mailers every month, or proactively notifying thousands of customers of situations that can really improve their level of satisfaction, all while actually reducing your office workload. This screenshot shows you how you can target customer communications from the map. Customer locations are shown by the colored flags, which indicate each customer's water usage pattern. And you can drill into a customer by clicking on the flag. Other map layers can include water main distribution lines or valve locations, which can easily help you determine which customers are going to be affected during a service outage. And then by clicking your mouse or tapping your finger if you're on an iPad or Android tablet, you can quickly geofence or select the impacted customers, and then hit the message button, choose a predefined message template, hit send, and off the messages go. It's that easy. Can be done very quickly from the office or from the truck, the service truck, if you've got an internet enabled tablet or laptop. You can also enhance your customer communications by embedding our interactive data-rich widgets into your existing website. A couple of examples are shown here. Our interactive service area map can be embedded on the public portion of your website, and it shows various GIS layers on top of a Google map, so it's interactive. The user can pan around and zoom in and zoom out. But the layers include, of course, your CCN service area and the boundaries of any surrounding cities or neighboring systems. And the idea is just to make it easy for potential customers to determine if they're served by your utility or not. And as service incidents are logged into the system, like we saw on the previous slide, they'll appear on this map, making it easy for the public to be aware of any water outages at a given point in time. And some of our customers have told us that local fire departments also monitor this map um, in the dispatch mode to see where there may be water supply or pressure issues. The other widget shown here is for customer water usage, and it shows the customer their monthly usage and how that compares to other customers like them. And if you have AMR meters that can data log, or if you've got an AMI system that provides hourly usage data on a continual basis, this widget will allow the users to interactively explore that information as well. Reducing water losses is always a priority, but in many parts of the country it's really becoming increasingly important as this drought, for example, that we're having in Texas and California is beginning to result in some serious supply limitations in some areas, and in other areas, we're seeing state legislatures beginning to take some pretty drastic action. We provide a number of system functions that help utility management detect and monitor losses and also react more quickly as the loss profile within the distribution network changes. These functions work by pulling together the data from your SCADA system and your customer metering system and your GIS, and along with a variety of measurement devices that can be deployed throughout the network, including pressure sensing devices and acoustic listening leak detection devices. On the customer side of the meter, we'll detect leaks and automate customer notifications through analysis of your meter data. Within the distribution system, we allow you to monitor loss rates through our zone-based loss analysis dashboards and reporting, and to detect leaks through monitoring of mainline pressure and localized leak detection monitors. You can also reduce apparent losses using data analysis to help you identify under-registering meters and right-size meters. This screen shows our water loss analysis dashboard, which combines data from your SCADA system and your customer metering system to produce a zone level loss analysis on a monthly basis if you have manual read or AMR meters, or on a daily basis if you have AMI on the customer metering side. And what we do is we model the physical topology of your distribution network into the software and tie in the SCADA, the mainline meters, through the SCADA system that represent the inputs into the system and any wholesale outputs out of the system, and then correlate the customer meter data by zone, also taking into account net changes in stored water in various tanks in each zone, and also pulling in known losses through line flushing or fire hydrant use or whatever those incidents may be. And all of that goes into the calculation, and it automatically generates your loss analysis at a zone level on a recurring basis. So you can really, the idea is to give you the ability to see quickly as the loss profile in a given zone may change over time, because a lot of times you have leaks in the mains. Significant leaks can occur, and they're just not readily evident by looking at the system. They don't necessarily cause a sinkhole or a geyser, depending on the soil in your area. They may just go down into the ground. So this helps you quickly see when things change as far as the loss profile in the distribution system. This screen shows you our leak repair visualization capabilities. The one on the left is showing you repaired leaks, and this is pulling data from your service order system or work order system, and it's showing you in one screen the location of leaks that have been repaired. The size of the circles is scaled depending on the estimated loss or the size of the leak, and the color gives you an indication of how recently this happened. So the most recent ones appear as dark red, and then over the course of time they fade out. And so this really gives you a quick visual to really absorb a lot of information. This one was created at the request of a customer, a GM who was having a hard time convincing her board of directors that several main lines needed to be replaced, and she came to us and said, I need something that's a more effective communication tool than a stack of service orders. And so we created this visualization for her, and this is updated dynamically during the day as new service orders, leak repair service orders are logged into their service order system. The other screen here is showing you the locations and the status of field deployed leak detection devices. Green ones are indicating no problem. I think there's a gray one here which is indicating it's having communication issues or it's dead for some reason. And then we see this blue one here, and this is indicating that this one thinks that here is a leak. So the idea is that we use the zone-based loss analysis that we looked at on the prior slide to frequently updated from data pulled from our existing systems, SCADA, customer billing, to let us see at a zone level where our loss profile may be changing. And when we see something drastic happening there, we can then deploy these field devices to help us zero in on the exact location of the leaks. And then of course we've got the leak repair visualization screen that helps us kind of look back and from a management reporting perspective see what's happened and where we've been making repairs in the system to help us identify where we may need to make further infrastructure investments for improvement. This screen shows a series of screenshots from a real-world scenario that highlights again the value of a combined analytics and messaging solution. This customer has several areas in their distribution network where they've got mains that are old and they're in some really shifty soil. And so especially lately, this customer's local in Central Texas, and especially here in the last few years with drought interspersed with a few torrential downpours, their soil just moves a lot and they've had a lot of problems with some mains breaking. So what they did is they deployed some pressure sensing devices on the mains, and what we see in the upper left here is the trend line on the pressure, and we see where we had a low pressure event happen that was detected by the software. This drove automated text messaging and email notifications to the management team at the utility. And they were able to roll trucks and very quickly find where they had the leak. And then in the upper right here you see where they used our field notification module to send a proactive outbound communication to all the customers in that area, letting them know that there was a leak, that they were aware of it, that they were on site to make a repair as quickly as possible. And I think the customers probably appreciated that, given that it was, what's it say there, 7, not even 8 o'clock in the morning. So people were probably looking to get in their showers, and were glad to know that even though the water was out, they were glad to know that the water utility was on the scene and trying to get it up and running as quickly as possible. And then they got the system repaired, and through the work order interface, it was automatically logged in the system for ongoing reporting and analysis, like we see in the bottom screenshot there. Conservation's an interesting topic for utilities. There aren't many businesses that will actively encourage their customers to use less of their product. And I know that some utility managers just are not interested in this. But I think it depends a lot on the regional and local supply issues, and also somewhat on the personal philosophy of a given utility's management team. But we do have a number of customers that are taking conservation very seriously. As you know, Texas is in the middle of a historic drought. And at the same time, we've got thousands of people every day moving into the state. And we've got this oil and gas boom that's through fracking is just sucking huge volumes of groundwater to support the production. I attended a talk given by the CFO of the San Antonio water system last year, and he was describing the financial benefits of the investment that they've made in conservation over the past 30 years. And to him, it's simple. Look at the big picture capital costs of providing ample water supply to the city. Compared to 30 years ago, San Antonio is using only 20% more water to support a population increase of 80%. So they've gone from 225 gallons per capita per day down to 140 gallons per capita per day today. But here's the kicker. In the process, they've been able to forego the construction of 2 water treatment facilities. And he reckons that saved the taxpayers of the city over $1 billion. So obviously conservation campaigns like what SAWS has done are large, multifaceted strategies, but technologies like H2O Analytics can play a part in a number of ways. A lot of behavioral psychology research indicates that information can really be a powerful motivator for individuals to reduce consumption. In particular, just showing people how their usage compares to their neighbors has been shown to be a really strong motivator. And personalized conservation tips can be driven from account level and property level demographic attributes and can be coordinated with other initiatives. So for example, by matching location data with county appraisal data, we can augment the information that you have, and we can then know, for example, what year was a house built. And so you could coordinate communication about low flow fixture replacement programs, but only target it to customers who live in older houses, for example. And making water usage data easy to access for your customers, and also sending automated notifications when usage spikes occur can help reduce waste and eliminate customer service contention issues. And for utilities implementing usage restrictions, we can program your use restriction rule sets into the H2O Analytics system, and then the analytics engine will constantly evaluate hourly usage data and detect likely use restriction violations. And then the system will automatically generate notification letters in a Microsoft Word format. And the system also generates a host of usage statistics that are broken down by customer type, production, consumption, per capita consumption, etc., and shows these as trends and over time. And all this is just reporting is in support of the regulatory reporting requirements that are driven by a lot of different state regulatory agencies. One of the key elements of the analytic engine is the usage profiles that the system calculates and maintains on every meter. This screen shows us a couple of views of that. The top one is just representational of how the analytics work, and the bottom is an actual screenshot of one of the chart representing one of the usage profiles. At the top, what we see is a distribution. Most of your customers are going to cluster around the mean. So what we see there at the peak of the curve, most customers are going to cluster around that average, that mean, and customers who are a little below average are going to be blue, are going to be color-coded blue. Customers that are a little above average are going to be color-coded green, elevated yellow, and then customers who are consistently really high water users or whose usage has spiked will be red. And on the other end, the other outlier, the gray represents customers whose usage is consistently very, very low or whose usage has dropped off. So this is just a simple segmentation mechanism that lets your management team very quickly visually discern different classes of users in terms of usage profile. And then these color-coded flags also come into some of the customer communication around conservation. And the idea is just to give the customer a very easily understandable visual cue as to how their water usage compares to other customers within the system. At the bottom, we see a screenshot of an actual usage profile for a customer, and What this is showing us in the red line is this is showing about 4 years worth of data for a customer. The red line is showing their actual monthly usage consumption. The blue line is showing a moving average for this customer. And as we can see, their usage spiked up here at the end in September. So this actually got caught by our leak detection algorithm, and this triggered an automated outgoing communication to this customer to let them know that their usage had spiked. We also see in the background shaded regions, the green and the yellow represent system-wide, and this is a residential customer, so those represent system-wide normal usage ranges for all residential customers in the green, and then the yellow represents elevated usage ranges for residential customers. And then of course anything above that is very, very high usage. So kind of the norm today is water utilities will give you a little bar chart that shows you on your bill, shows you your last 12 months of usage. Now, that's better than nothing, but that's 12 data points. And what we see on this chart is several hundred data points giving us a lot more context about what our usage has been over a much longer period of time, but also critically how it compares to other customers like me throughout the system. As you can see on this next screen, this is an example of an actual conservation email. The system is going to automatically generate one of these every month for every customer for whom you have an email address. And the content of these is dynamically personalized for every customer every month. So at the top we see that usage chart that we just looked at. We see their water score, the red flag, and the reason codes why they were flagged red this month. And then at the bottom we see conservation tips, and these are driven by a rules engine that takes into account the demographics of the customer's usage pattern, and also the enhanced property demographics that we get through our appraisal interface. So we can tailor conservation tips like we talked about earlier based on the age of the property, or other examples might be whether they have a swimming pool or whether they have an outdoor irrigation system. We've mentioned quite a bit external data sources. Now, there's a lot of added value that comes into an analytics solution through the application and matching of external data sources. A few that we pull in: county appraisal data. We've talked a little bit about this already. Another thing we use it for is geocoding of location records. So a lot of times customers, when we implement the system, they may have GIS for their distribution network and their production facilities and distribution facilities, but they may not have geocoded all of their customer meters. So we can geocode based off of location address matching to get you kind of a rough-grained, house location, which is good for our customer notification module. Also, what we've talked already about the enhanced location demographics, and other areas where we've used county appraisal data, we can help customers locate old houses within their distribution system to satisfy environmental requirements around lead testing. We can also use it to identify multiple connections to satisfy one connection per household requirements that are coming out of in a lot of states now. The federal census data is very useful in population analysis and also in customer demographic analysis. And we've recently introduced a weather data interface that is tied into about 8,000 nationwide weather stations that are hosted by the National Climate Data Center and also Colorado State, their Colorado Climate Data Center, which is nationwide. And we're doing a couple of things with this data right now. We just introduced it, and right now it's really just helps you visualize and forecast system-wide demand and how it correlates with weather events, temperature, and precipitation events. In the future, we're going to be using this as a foundation to some additional enhancements that are going to allow tailored property level water budgeting that will take into account evapotranspiration rates and help your customers easily visually see how their actual water usage compares to what they really need to be using based on the personalized water budgets. Thanks for your time and looking at the presentation today. You can find a lot more information about the system at H2O Analytics.com, or please give us a call if you want to take a closer look, 512-788-3000.